This next example is a little bit different from the last few because we have to do a little bit extra thinking with this bottom because we're trying to get it so that we can take the fourth root of whatever is going to be on the bottom of this rational expression, because again, we don't want the radical in the denominator. So thinking through this, we know that the a, we're going to want it to be a to the fourth. So whatever we multiply by is going to end up having a to the third next to that. Then we have to figure out, okay, what can I take the fourth root of? And so if you go through and do some guessing and checking, we end up finding that it's 625, and we get that from just doing 25 times 25. So that works out nice with getting it so that we can take the fourth root of this expression once we multiply that out. And again, we're going to have to do the same thing to the top. So we're going to multiply by the fourth root of 25, a to the third on the top. And so working through this question now, we're going to end up having on the bottom, we're going to have the fourth root of 625 times a to the fourth, again, all underneath the radical there. On the top, we're going to actually be able to do the 3 times 25 and get 75. So we'll have the fourth root of 75, and then a to the third, b to the fifth. And then now, with the bottom part of this, taking the fourth root of that, you would end up with just 5a, which is great because that's what we want. We don't want a radical on the bottom, so that has all been taken care of. The top now, we're going to go through, and we just have one step to simplify this further. We can't take the fourth root of anything, any factor of 75. We can't take the fourth root of a to the third power, but the b to the fifth power, we can think of this again as b to the fourth times b to the first power. And so we're actually going to be able to take the fourth root of b to the fourth. So we're going to write that, we'll write it out front. So we'll have the fourth root of b to the fourth, and then we'll leave everything else together because, again, we can't do anything further with that. So we'll have 75a to the third, and then there will still just be a b to the first power underneath that radical still. And then taking the fourth root of b to the fourth, we're going to end up having just b, and then it's going to be all multiplied by this fourth root of 75a to the third b over 5a. For the next question, again, we need to rationalize the denominator because we have a radical symbol there and we do not want that. And in this question, again, it's kind of like the last one where we have to do a little bit of thinking through of, okay, we need to be able to take the cube root of whatever it is on the bottom. And so we're going to be multiplying by something that's going to allow us to take the cube root of it. In this case, we're going to multiply by 6y. And the reason we're multiplying by 6y is because 36 times 6 is going to be 216, which you can take the cube root of. And y to the fifth times y to the first is going to be y to the sixth, which again, you can take the cube root of. So on the top here, we're going to be multiplying by the same exact thing. And so now on the top, we're going to have the cube root of 2 times 6, which is 12. And then we'll have x squared y all over the cube root of 216 y to the sixth. So moving forward with this question, the top we can't do anything further with, so we're just going to leave this as 12x squared y. And then on the bottom, the cube root of 216, as mentioned, was 6. And then the cube root of y, there's a couple ways you can think of this. Again, you could break it down so that you have, again, the cube root of y to the third times the cube root of y to the third, right? Because y to the third times y to the third would be y to the sixth. Taking the cube root of each of those, you would end up having y times y, which is just y squared. And so that would be the final answer. For number 42, again, we need to rationalize the denominator, and this one's a little bit different now because we have 2 terms on the bottom instead of just 1. And so to rationalize this denominator, we're going to use almost what you can think of as the opposite. So instead of multiplying by the same thing, 5 plus the square root of 6, we end up multiplying by its conjugate, which is going to be 5 minus the square root of 6. So we're going to be doing that to both, again, the top and bottom of this rational expression. So now we're going to end up having negative 4x times this entire quantity of 5 minus the square root of 6. And then here on the bottom, we're going to have 5 plus the square root of 6, and then 5 minus the square root of 6 multiplied together. So what's going to end up happening here is when we have to go back to our difference of squares rule, and this is going to be that same idea. So you could go through and use FOIL, but if you can recognize this as being the answer to a difference of squares, it makes it a lot quicker of a problem. And again, that difference of squares, we have basically a squared minus b squared equals a plus b times a minus b, which is the same situation that we have here. So if you can keep this in mind for these questions where you have to rationalize the denominator with two terms, this is very, very handy. Otherwise, like I said, you can go back to like what we did on question 16 and question 18, where basically you use FOIL. You'll get the same answer. It's just going to be a little bit more involved and a little bit more work to get to the answer. So if we use this difference of squares rule, what's going to happen is we're going to end up having on the bottom here, a is going to be 5, so you have 5 squared, and then it's going to be minus the square root of 6 squared. So right there is why we end up doing this multiplication by its conjugate, because when you have the square root of 6 squared, you end up with just 6, because you think of it as the square root symbol as canceling out with the squaring there, which is perfect because that's what we want to happen. On the top now, if I go through and distribute, we're going to be taking this negative 4x times the 5 and this negative 4x times a negative square root of 6. We'll end up with negative 20x and then plus 4, and then we'll write it as the square root of 6x. And now on the bottom, we're going to have 25 minus 6, and again on the top here we have negative 20x plus 4 times the square root of 6x, and then our final answer is going to end up being negative 20x plus, and then we'll have 4 times the square root of 6x, sorry I ran out of space on my paper, and then on the bottom you have 19. And so we have that expression over 19.